Conic sections, dear students, one of the most important topic in coordinate geometry. We have observed a lot of different shapes and curves around us. For example, steering wheel of the car, tires of the car and vehicles are the simple example of a circle. When a ball is thrown upward, it reaches to the maximum height and comes down to the ground. The path that ball follows makes a curve that is parabola. When a football When a player hits a football, it reaches to the maximum height and comes down to the ground. That path makes a curve that is also a parabola. Another example that exists in nature is rainbow. Rainbow is an example of a parabola. Another application of the parabola is car's headlight. The car headlight reflector is exactly the same as the shape of the parabola. And a dish antenna use the shape of parabola to receive signals. It's a very good example of a parabola. Another shape we discuss here is ellipse. When we look at the orbit of the earth, we observe that it's a circle, but it's actually not a circle. It's an elliptic orbit. Its orbit, its path followed by the earth around the sun is actually a ellipse. Another shape that is hyperbola. The same axis used by two different curves which are opposite in direction. Its use in the use of hyperbola is in telescopes and engineering. Let's discuss conics conic sections. Conics means cones, two cones, and sections means different type of sections that are obtained. Sections means different type of curves that are obtained by when we cut the cones by a plane. Let's suppose these are two cones here. If we cut the cone by a plane horizontally along x-axis, this is its vertical axis. You can assume it as perpendicular. Okay, you can say that it's a y-axis. When along x-axis, when we cut this cone, that cone makes a shape that is circle. When we tilt this plane little bit upward, then we cut the cone, it makes a shape that is ellipse. If we tilt more little bit and cut the cone, the shape obtained by cutting that cone is parabola here. When we when we tilt more this plane comes parallel to the perpendicular axis, and after that we cut the cone, two different cones here. So this plane makes two different curves along the cones. So these cones are makes a shape that is hyperbola. These cones after cutting by a plane makes hyperbola. So these four types of shapes categorized in a same sections, these are conic sections. So let's discuss about circle first. After that we will discuss about parabola and ellipse and hyperbola. Dear students, first topic of conic sections is circle. We here define a circle definition, its geometric form, its equation of circle, and in standard form and in general form. So let's discuss about definition first. Set of points. Set of points, or we can say locus. Locus of points which are at a at a fixed distance from a fixed point is circle. This is definition of a circle. So let's understand fixed point first. Let's suppose we can take any point in the plane which is this point. This is fixed point. So set of points from a fixed set of points or locus of points, we can say these are set of points. Set of points from a fixed point which are at a fixed distance. So here is a set of points. Let's suppose these are set of points. If we take the distance from this fixed point, these distance are different from all other distances. So we cannot take such points here as a cluster, as a locus. Okay, the points, the points in this form here, here, here. So these type of points are the only way to describe the definition of a circle. For example, here the distance of this point from a fixed point is same. All these points have the same distance from the fixed point. So these points satisfy the definition of a circle here. Okay. If we draw here a circle and this is a fixed point, so this circle is made by locus of the point, the set of the points. So its distance from this fixed point is same. These are, let's suppose this is a point, any arbitrary point, any point. So we can say that this fixed point is the center of the circle. Okay. If we take the distance between this point and the center is r, then radius is equals to r, and diameter, it is equals to 2 times r, because when we extend this r to this point, this r plus this r becomes 2r, so diameter of the circle is 2 times r. Okay, we have geometric form of the circle, but to solve problems, to solve different type of questions, we need to express this geometric form into algebraic form. Means to say, to express into algebraic form, we need to find its equation of circle. Next question is to find equation of circle. Let's suppose we had this circle here. Its center is here. We take any point P into X and Y. We draw a line from a fixed point to the radius. So take center points as H and K, any arbitrary points in the plane, and take R is equals to radius. So you know that distance formula. By distance formula, D is equals to x2 minus x1 square plus y2 minus 1 y1 square root. If we use this distance formula to find the equation of a circle, here put the values of P and C. C distance becomes x minus h whole square plus y minus k whole square root. So Because the distance between P and C is R, so we can represent as R. So x minus h whole square plus y minus k whole square root. Squaring on both sides, we will get x r square equals x minus h whole square plus y minus k whole square. So this is the standard form of equation of a circle. This equation 1 is the standard form of equation of circle. We can arrange it as x minus h whole square plus y minus k whole square is equals to r square. So this is equation of a circle. If we draw this circle on a plane, this is already in a plane. But if we take the center as h and k as 0, 0, here is the center 0 and 0, and draw a circle here. So put the values of h and k as 0. So x minus 0 square plus y minus 0 squares is equals to r square. So x square plus y square is equals to r square. This equation 2 is the equation of circle. Which circle? That circle center lies on a origin, that is origin of the plane, which is 0, 0 points. So equation of a circle x square plus y square is equal to r square is a special type of circle that lies on origin only. Now moves to the next topic, that is general form of equation of a circle. How this general form of equation of circle is obtained? General form of equation of circle is obtained by expanding the standard form of equation of a circle. X square minus h, sorry, x minus h whole square plus y minus k whole square is equals to r square. If we expand these squares, so x square plus h square plus, sorry, negative minus 2hx plus y square. Here we are going to expand y minus k whole square. So a minus b whole square equals a square plus b square minus 2ab. Simply we will use the formula here. y square plus k square minus 2ky, which is equals to r square. Arrange this in x and y form. X square plus y square minus 2hx minus 2ky plus h square plus k square is equals to r square. Now take the r square into left side. So x square plus y square minus 2hx minus 2ky plus h square plus k square minus r square, which is equals to 0. Put minus 2h is equals to 2g and minus 2k is equals to 2f and c is equals to h square plus k square minus r square. Here we note that 2 will be cancelled by 2 and negative sign will shift towards g. So h becomes negative g and k becomes negative f. Put the values of x, h and k into the value of c. So c becomes negative g square plus negative f square minus r square, which is equals to g square plus f square negative r square. If we take C towards right side, if we shift C towards right side and R towards left side, here R to this side and C to this side, then we will get R square is equals to G square plus F square minus C. So R becomes G square plus F square minus C square root. Here are two possible values, plus and negative, but we will take only positive value because distance is never negative. So that's why radius is the distance between 2 points, so we take distance as positive value. So here we will take only plus value. If we put the values of h and k in an above equation, we get x square. We will put the values of h and k in this equation here. So x square plus y square minus 2 into minus g x minus 2 into minus f. Here we note that h square plus k square minus r square is equal to c. So we take simple as c is equals to 0. So x equal x square plus y square. So negative times negative is equals to positive. So 2gx positive plus negative times negative is equal to positive. That's why we write here as a positive. So 2f, here is y, 2fy plus c equal to 0. This equation 3 is an equation, a general form of equation of a circle. So if we draw, when we draw this circle here, its center will be, because h is replaced by my negative of g and k is replaced by negative f, then its center will be negative g and negative f, and its radius from this point p upon p into x and y, its radius will be g square plus f square minus c square root. So in general form of equation of circle, we will take the radius as g square plus f square minus c and center negative g and negative f. So we have equation of circle in standard form. Here equation 1 is the standard form of equation of a circle. But why we need to find the general form of equation of a circle? So for this purpose, we have to come to this question. So this question shows that the equation of a circle is x square plus y square plus 6x plus 4y plus 2 equal to 0. So represents a circle. Find its radius and center. So for this type of question, we need to have a general form of equation of a circle. So we convert the standard form of equation of a circle into general form to solve our problems very easily. So our question is x square plus y square plus 6x plus 4y plus 2 equal to 0. So general form of equation of circle is x square plus y square plus 2gx plus 2fy plus c equal to 0. And we already know that in general form its center is negative g and negative f, and its radius of the circle is g square plus f square negative c square root. So comparing, this is equation 1, let's suppose this is equation 2. So comparing these values of equation 1 and equation 2, so 2g becomes, the coefficient of x square is 1, so coefficient of y square is 1, so coefficient of x is 2g, so 2g is equals to 6. The coefficient of y is 4 and the coefficient of y and 2 is 2y, so 2f is equals to 4. Here c equals to c in 2, equation 2 is c, and then equation 1 is 2, so c equals to 2. So here G becomes 3 and F becomes 2. Already C value is 2. Put the values in center equation in the coordinate of a center. C becomes negative 3, negative 2, and the radius becomes negative 3 square plus negative 2 square negative 2 square root. So 9 plus 4 negative 2 square root, this becomes 11 square root. So radius is 11 square root. Let's come to the other question, that find the equation of a circle with center 2, 3 and radius is 3. Here we use our first equation of a circle, that is standard form of equation of a circle. So standard form of equation of circle is x minus h whole square plus y minus k whole square is equals to r square. Here our center is 2 and 3 and radius is equals to 3. So in standard form center is equals to h and k and radius is r here. So comparing the values of C center values, so h becomes h equal to 2 and k equals to 3. So put the values of h and k in equation, standard form of equation. So x minus 2 square plus y minus 3 square is equals to 3 whole square. So by expanding this equation, x square plus 4 negative 4x plus y square plus 9 negative 6y is equals to 9. So arrange this equation in the form of x square plus y square. So x square plus y square negative 4x minus 6y plus 4 plus 9 is equals to 9. So x square plus y square minus 4x minus 6y plus 4 plus 9. When we take 9 into here, into left side, then this becomes negative 9 which is equals to 0. So 9, positive 9 and negative 9 will be cancelled out. So x square plus y square minus 4x minus 6y plus 4 equals to 0. So this is equation of circle. So with the help of center and radius we can find the equation of a circle, and with the help of equation of a circle we can find the radius and the centers as well. So there are different conditions for equations of circle. Dear students, in conic section category there is a second topic, that is parabola. Before discussing parabola, let's understand what is eccentricity. What is eccentricity, which is denoted by E. E is the ratio of distance from a fixed point to the distance from a fixed line. In case of number 1, in case of circle, the value of eccentricity is 0. In case of parabola, eccentricity value is equals to 1. In case of ellipse, the value of eccentricity is between 0 and 1, and in case of hyperbola, the value of eccentricity is greater than 1. So we have understand that what is eccentricity. Eccentricity is the distance from a fixed point to the distance from a fixed line. So in case circle, eccentricity tells us about the shape of the conics. So comes to the topic parabola. Let's discuss its definition first before moving to the equation of a parabola. So a parabola is the locus or set of points which are equidistant from a fixed point and a fixed line. What does it mean? The parabola is the locus of points. Locus means set of points which are equidistant from fixed point and a fixed line. The main definition lies on these two things, that fixed point and the fixed line. So its distance from the equidistance from the fixed point and the fixed line. These set of points are makes a parabola. Let's suppose we have a point in the plane and a line in the plane as well. This fixed point is called focus, and the fixed line is called Directrix. Why we are discussing this focus Directrix? Because these are used in the following equations, and we will use the names of these focus, Directrix, axis of parabola, this and that. So we have a point in the plane and a line in the plane. So set of all these points which are equidistant from this point to this line. Let's suppose we have a point here, this point, and we have another point that is here. So in between these points there are a lot of many points here, but we are plotting these 2 points only. So first point, so distance from this point, by the definition, so the distance of this point from this focus, this is also called as a fixed point. We have already know that this is a fixed point. So distance from a point to the fixed point and from this point to the fixed line is equal. Means to say, if we take this point as B and if we take the point on the line is M, so PF upon PM will be equals to 1, because their distance are same. Let's suppose 2 upon 2 is equals to 1. So that's why, so distance between distance of a point, let's suppose this is a point. So here we can point out this point. So distance of this point from a fixed point and a fixed line is always 1. So this is the definition of a parabola. Let's take these points and draw a shape of the parabola. Let's suppose we had a fixed point here. Let's suppose these are the set of points. Okay, these are the set of points makes a parabola. These are from equal distance or distance from this point and this line. So this type of shape is made by the definition of the parabola. So the center is here. So what is center? Center of the parabola that divides into two equal parts. The point that divides the parabola into two equal parts. So let's define here a point that divides the parabola into two equal parts. So any line which is axis, now we are going to define axis of parabola. Axis of parabola. A line that passes from a focus. This fixed point is called focus. This fixed point is focus. A line that passes from a fixed focus and center of parabola and perpendicular to the directrix is axis of parabola. This line that passes from a fixed point, that is center, the line that passes from a center and a fixed focus, that is also called a fixed point, is called axis of a parabola, which is perpendicular to this directrix. We can denote directrix as L. We can denote the directrix as L. L is equals to directrix. Okay, we have drawn the shape of the parabola, but we also want to mention here that this parabola is along the positive side of the x-axis, above the x-axis line and the first quadrant of the coordinate plane. So here we draw its coordinate plane as, this is x-axis, let's suppose this is y-axis. You can draw as, this is y-axis. Okay, so here this point is, this point, this is the focus, this point is center, and this point is on the directrix. So we have to find the vertices of these points. So it is important to find the vertices for the equation of parabola. If we take the center as, points of the center as H and K, because it's above the x-axis and it's from the positive side of y-axis, so all these value H and K is also positive. So here is H and here is K. Okay, so here is H, the value of H, X on x-axis, and on y-axis its value is K. So the center of the parabola is the coordinates of center of parabola is H and K. So the distance from, center to the focus, let's say it's A. So the distance from center to the left side is also a, because the distance from center to the focus is a. So because this distance is also equal, so this can also be written as a. So overall distance from focus to the directrix is 2a. So let's say this is a. So we have to find the coordinates of directrix and the coordinates of focus. So because the center from the center to the right side, h is increasing, and here the value is how much increasing, because here the distance is a, so h plus a, the value becomes h plus a along x-axis. So h plus a along x-axis, y remains constant, so this is value of k. So the coordinates of focus along x-axis would be h plus a and k. If we goes this from this point, like if we are going to the left side of the center, then from the left side h is decreasing. So in this way, we how much there is decrease in the h, so there is a times there is a value, h will reduce. So we can write we can write the coordinates of this point, this directrix points, as h minus a and k. Okay, we are taking any point here, arbitrary point here, as p. Okay, so the point p, the coordinates of point P as x and y. Let's take any point, because we are not taking this point as a center point. So we are taking any point on the on this parabola, which is P of x and y. If we take this point along on a parabola, we have to take another point on the directrix line as well. So here we can take any other point on the directrix of the parabola. So here we notice that along our h minus a will be constant, because here we have taken already that h minus a, the along x-axis, the value of x-axis, the value of x will be h minus k, there will be constant value, but y is going to increase, y is going to increase. So here we can take any point of the y, so in general we can take the value of y as well. So first point of the this directrix line, this is a point, so we can represent this point as m. So so we can write it as coordinates of m would be first the value of x, the coordinate, what coordinate represents, coordinate represents value of x and y. Along x-axis what is the value, along y-axis what is the value. So along x-axis the value remains same, because this point is same along x-axis, so h minus a, and along y-axis the value is continuously increasing, so we don't know the value of k exactly, so we can take it as y. So now we have all the coordinates of parabola. Let's say we have focus, we have center, we have any arbitrary point on the parabola, and the point on the directrix. So we have all the coordinates of these points. So now we have to find the equation of parabola that satisfy all the other points. Let's say we have other points on the parabola. Let's say this point, this point, this point. So that equation must satisfy all these points of the parabola. So we have to find the general form of equation of a parabola in this case. So we need these coordinates of these points. So we know that PF distance upon PM distance for the parabola, it is centricity, and its value is 1. We already know that. So when we multiply PF distance to centricity times PM, then this becomes equal. Pf is equal becomes equal to E times Pm, the distance of Pm. Means to say Pf distance. What is Pf distance? So distance of P to F. We find this distance first, and we will multiply with E and the distance of P to M, this distance. So by finding these distances and when we multiply, so we will find at the end a general form of this equation of parabola. So let's find. We know that the value of E here in this case for parabola is 1. So this becomes Pf equals to 1 times Pm. Why we need to write absolute value? Because here we are discussing distances, so distance will always be positive, so that's why we are going to write this absolute value. So let's say Pf is equals to Pm. Now we have to find the distance of Pf equals to Pm. So if we find this distance, we will get a general form of equation of parabola. So let's discuss the distance formula as well. So distance formula equals x2 minus x1 square plus y2 minus y1 square root. Now we have Pf absolute value equals to Pm. So put the first of all write the distance of Pf. So here notice that we are going to find this distance first. So its P coordinates are x and y, and F coordinates are h plus a and k. So x minus into h plus a whole square plus y minus k whole square, which is equals to now Pm. Now we are going to find Pm distance here. So its coordinate are P coordinates are x and y, and M coordinates are h minus a and y. So this is a square root. So x minus into h minus a whole square plus y minus y square root. Squaring on both sides, we will get x minus h plus a whole square plus y minus k whole square, which is equals to x minus into h minus a whole square plus 0. So y minus k will remain here. So take the value of this expression to the right side of the equation. This expression will go to right side. So there is positive sign. So when it will go to the right side, it becomes negative. So x minus into h minus a whole square minus x minus into h plus a whole square. So we have to expand one by one these expressions, these formulas. So we already know that a plus b, a minus b whole square, which is equals to a square plus b square minus 2ab. So we will use this formula here. This is our, this value is our a, this value is our b, and here is negative sign, here is negative sign. So we will use this formula here. Okay. So expanding this formula, so y minus k whole square will be equals to x square plus b square means h minus k whole square, h minus a whole square plus minus 2 into x into h minus a. So here there's negative sign, so minus into x square plus h plus a whole square minus 2 into x into h plus a. Okay, now erase the above and simplify. If we erase this side, okay, take this side on above here. So y minus k will be as it is. So x square plus h minus a whole square minus, when you multiply 2x with h minus a, so negative plus multiply by positive is equals to negative. So 2hx, when this negative sign will multiply with negative sign, so this becomes negative negative positive 2ax. So we will multiply this negative sign here, so negative x here, negative multiplied by positive is equal to negative, so negative into h plus a whole square. So negative time negative is positive, so this is positive 2x. So this becomes this let's say this negative sign and this negative sign when multiply, it becomes positive. So this 2x will becomes positive. This will becomes 2hx plus 2ax. So let's simplify first. This here is a positive sign, so x square will cancel out. Okay, this negative 2, this negative 2hx, and here is a positive 2hx will cancel out. Okay, so this will also cancel out. So h minus a whole square plus 2ax minus into h plus a whole square plus 2ax. So 2ax plus 2ax equals to 4ax. So 4ax plus h minus a whole square minus h plus a whole square. So expand these whole squares as well. So 4ax plus h square plus a square minus 2ah into h square plus a square plus 2ah. So 4ax plus h square plus a square minus 2ah minus h square, when this minus sign will multiply, so minus a square minus 2ah. So this h square will cancel out, a square will cancel out, so this becomes 4ax minus this minus 2ah will be equal to plus will be equal to negative 4ah. So this becomes 4a will be common in these two terms, so x minus h. So we can write as here we can write as y minus k, y minus k equals to 4 square is equals to 4a into x minus h. So this is general equation of a parabola. So if we put the values of k and h equal to 0, we have already know that center points are h and k. So if we put center points as 0 and 0, the center is lying on origin, then h and k will be 0. So this equation will becomes y square is equals to 4a x. Because this parabola lies above in first quadrant, so that's why its value becomes y minus k whole square equal to 4a into x minus h. So this is general form of this parabola. So let's say different types of parabolas. For example, x square is equals to 4ay. If the parabola is along the along the this side here, so its value becomes y square is equals to negative 4ax. Okay, its general form will be this. So the parabola that is faces above the x-axis, its general equation will be x square is equal to 4ay. If the parabola faces downward to the y-axis, then its equation becomes x square is equal to negative 4ay. Latest rectum of the parabola. What is latest rectum of the parabola? So let's so what is chord? First of all, we need to understand what is chord. Chord. Any line, any line that touches two points of the curve is called chord. For example, this is a curve. This is a curve. A line that touches two points of the curve. Here this point and this point. This line is touching two points of the curve. So that is chord. This line is chord actually. So any line that touches two points of the curve is chord. Here any focal chord, the word is focal chord, means to say a line that touches focal chord. Let's say this is line. So it's a focal chord because it touches two points of the curve and passing from a focus. So that is focal chord. So any line that is focal chord and passing perpendicular from the axis of the parabola. Here is the axis of parabola, and if this focal chord is passing perpendicular to this this axis, and must be a focal chord. Okay, so it is called a latest rectum of the parabola. So to find the latest rectum of the parabola, if we have already know that the focus points are a and 0. So here the value of x axis, the value of x coordinate is a. Here would be a will remain same along positive and negative side of y axis. So the value of y we have to find. So put the value of this a into equation of parabola for facing right side of the x-axis. So its equation is y square is equal to 4ax. If we put the value of this x into this, here we have put this value. So 4a into a, which is equals to 4a square. If you're taking square on the both sides, this will value becomes positive negative 2a. So positive 2a will be above the x-axis, y-axis, and along positive y-axis, and negative 2a will be along the negative y-axis. So the length of the latest rectum would be, because length is basically a distance between 2 points. So if we take the distance, a minus a will be cancelled out. So negative 2a and negative into negative 2a will becomes 4a square when take square root. So just like here, a minus a whole square plus into 2a negative into negative 2a whole square root. This is the length of the latest rectum. So a square will be 0 plus this becomes 2a plus, again this is negative 2a whole square root, which is equals to the 4a 4a whole square root will be cancelled out. So this becomes 4a. So length of latest rectum will be 4a.